Hi guys, good morning to one and all. This is G Pencil. I am studying second BTech in Shankara College of Institution and Technology. Today we can learn for my TikTok presentation in data analysis algorithms, what is sorting techniques and introduction with time complexity. First we can go for today's we can discuss about the what is introduction and different sorting algorithms and sorting by distributions. Introduction. Sorting task is nothing but given an array x of 0 and x of 1 and x of size minus 1 and reorder entire so that x of 0 less than or equal to x of 1 less than or equal to x of size minus 1. Here list is non-increasing order. We can also sort a list of elements in non-increasing order and sorting example and original list we go for 10, 30, 20, 80, 70, 10, 60, 40 and 70. In this original list is it is a not sequence, it is a increasing to decreasing or either it may be decreasing to increasing and sorting the non decreasing order 10, 10, 20, 30, 40, 60, 70, 70, 80 and sorting in non increasing order 80, 70, 70, 60 and 40, 30, 20, 10 to 10 and sorting problem. And what do we want to data sorted in order, unordered list to sorted list. In the sorting index is 0 and ending index is size minus 1 and issues in sorting and many issues are there in sorting techniques. Those are how to rearrange a given set of data, which data structures are more suitable to store the data and prior to the sorting and how fast the sorting can be achieved, how sorting can be done in memory constraint and situation. Constraints is nothing but condition. How to sort various types of data. Sorting algorithm. First, there are so many sorts with it. Basic operation involved in this type of sorting techniques is comparison. A data item is compared with the items in the list of items in order to find its place in sorted list. Insertion, selection, exchange and enumeration. Sorting by the comparison. Sorting by comparison insertion from a given list of items. One item is considered at a time. The item chosen is then inserted into an appropriated position relative to the previously sorted item. The item can be inserted into the sum list or to a different list and insertion chart. And sorting by the comparison selection. First, the smallest or large item located at the separated from the reset and selection sort, heap sort, selection by the comparison. And if two items are found to out of order, they are interchanged. The process is repeated until no more exchange is required. And bubble sort, shell sort, quick sort and sorting by the comparison and enumeration. Two or more input lists are merged into a output list and while merging the item and enter of list is chosen following the required sorting order and merge sort. Sorting by the distribution and no key comparison takes place. All items under the sorting and distributed over an auxiliary storage space based on the constraint and element in each and then grouped them together to get the sorted list and distribution of item based on the following choices and radix. An item is placed as piece and is decided by the basis or radix of its component with which it is compared of counting. Counting is nothing but items are sorted based on the and relative counts and hashing. Hashing is nothing but items are hashed, that is a disparity into a list based on the hash function. Note this lecture constraintsly on the sorting comparison and insertion sort. Insertion sort is nothing but general situation and smallest element sorted and remainder unsorted. Size 0 and size minus 1. Compare this shift till x index of I is larger and insertion sort and algorithm for insertion sort. Void insertion sort bracket of int list array bracket int size. Next curly bracket int I comma j items and colon for I is equal to 1 I less than size colon I plus plus. It is a for loop is initialization together in out code of internal code. Next we can go for j minus 1 and j greater than equals to 0 double ampersand list of I greater than item and list of j plus 1 is equal to list of j and list of j plus 1 is equal to item colon close curly bracket. It is a out of the code in the insertion sort. Next we can insertion sort example and case 1 it is a input list of already in sorted order. Next we can go for the number of comparison in each insertion. It is a c of 1 is equal to c of n is equals to 1 plus 1 plus 1 and up to n minus 1th iteration. Number of moment no data movement takes place in any iteration. M of n is equal to 0. Insertion sort complexity analysis. Number of comparison c of n is equal to 1 plus 2 plus 3 plus and so on plus n minus 1 is equal to n of n minus 1 by 2. Number of movement takes place in a ith iteration with I. M of n is equal to 1 plus 2 plus 3 and so on plus n minus 1 is equal to n of n minus 1 by 2. Next insertion sort complexity analysis case 3. If the input list of random order let p1 let be the probability that key will go to ijth location I greater than is equal to j less than is equal to I plus 1, then the number of comparison will be j dot pj. The average number of comparison in ith plus 1th iteration is a plus 1 and summation of j equals to 1 to j plus 1 j into p of j. Assume that all keys are distinct and permutations of key and quickly likely p1 is equals to p2 is equal to p3 and so on is equal to p I plus 1 is equal to 1 by I plus 1. This called insertion sort time complexity. Next we can go for selection sort. Selection sort is nothing but general situation smallest element sorted and middle of the element to go for k and remainder unsorted steps. Find the smallest element and m value and in x of k sizes and swap the smallest element with x of k then increases k. Thank you friends and given opportunity. It is a brief explanation about the sorting techniques in data analysis algorithm. Thank you.